And so, I have a question.
Excuse me, but can you give us a rundown a little bit on what glyphosate is in that we would eat?
I could. Anything with any of the genetically engineered plants is going to contain glyphosate.
Like bread?
Anything that is in any plant that is desiccated with glyphosate that's not genetically engineered will probably also contain glyphosate.
Because of this promiscuity factor that you...
Well, you're putting it right on the plant, and at that late stage of development, the only place that the glyphosate can go is going to be into the seed. I'll show you a little schematic.
So do I understand right that the glyphosate is man-made? It's not something you find in nature. It is this monster.
It's a man-made compound.
Okay.
Roundup.
Now, when we talk about chelation and that effect, I can explain it probably a little better with this diagram up on the screen here. I've depicted the enzymes that you have in a plant that are really powerful machines for you, powerful motors. And then you have a little key that you use on those. We call it a cofactor, that is the catalyst or the key that turns that engine on. So you can have a 200 horsepower engine out in a car anymore, or 400 or 800 horsepower in a big tractor or a truck. Can do a lot of work for you, but it doesn't do anything until you turn the key on. If you want to turn it off, pull the key out of the ignition. The way we pull the key out of the ignition for those physiological processes is with the chelators, because it's manganese and magnesium and copper and zinc and magnesium and even a couple of enzymes, or a few enzymes for calcium, cobalt, nickel, and all of those elements that we don't have to have a lot of them, but we have to have the keys. And those elements are the keys, and those are the elements that are immobilized by glyphosate. So that when you pull the key out, you shut the system down. All of our herbicides, and again, many of our other pesticides, insecticides, and whatnot, are chelators. That's the mode of action, or that's the way that they function, is to immobilize the key or pull the key out of the ignition. EPA was told by Monsanto that glyphosate only inhibits the EPSPS enzyme. That's an enzyme at the start of the shikimic acid pathway. They said that man and animals don't have this pathway, so it can never be toxic, and we don't need to do any safety studies on it because it's impossible to be toxic to animals and man. It's through the shikimic acid pathway, though, that we get our aromatic amino acids. You get your serotonin and melatonin and your dopamine and all of that through the tryptophan, through your tyrosine and your phenylalanine, all become very important precursors for other compounds in your body, but you can't make them yourself, but your gut microorganisms do. That's where both the chelation effect and also the antibiotic effect of glyphosate impact each of us very directly. But rather than just one enzyme that's inhibited, we find that glyphosate will actually downregulate 291 enzymes at least. This is just a small portion of those, and you see the EPSPS at the bottom that is about halfway in that 291 enzymes as far as degree of downregulation. When you disrupt the system, then there are about 30 enzyme systems that are increased or upregulated, but 291 that are downregulated. Tremendous change and physiology. So, as you look at that, we know that glyphosate's been a very powerful tool for us in agriculture for weed control. Simplified many of the management decisions. It's a systemic chemical. You didn't have to have good coverage. You can just spray it out, get it on the plant, and it moves through the plant because it's systemic. It accumulates in the shoot tip, the root tip, reproductive structures, and legume nodules. And again, 80% will stay in the plant for the life of the plant. 20% moves down into the root system, and if it can't move into the root system, it won't have any herbicidal effect, because it's as it moves down into the root system that it shuts down the plant's defense mechanism. It's the soil. I know you can't drown a frog, but I tried. But it's shutting down that defense mechanism, or essentially giving the plant a bad case of AIDS, that then makes it susceptible to all of the soil-borne pathogens that are the actual herbicidal mode of action of glyphosate. It moves down out of the soil. Its antibiotic activity is against the good bacteria, not the pathogens. The pathogens are resistant. Fusarium, Rhizoctonium, Pythium, Phytophthora, Rhinosperm, Monomycete, all of those very serious diseases that we have to worry about from the soil-borne pathogens, those organisms are all stimulated. It's a Pseudomonas bacillus. And those organisms that control those or suppress them, that are sensitive to the glyphosate. Those organisms that increase the availability of our iron and manganese and other nutrients are your nodule bacteria that fix the atmospheric nitrogen for our legumes, are all very susceptible to glyphosate. So that as the glyphosate moves through the plant, it accumulates. It's going to be there for the life of the plant. 20% or so will move out of the root system. Anywhere the roots go, you're going to have glyphosate. If you're going to degrade it, that's going to take place in the top foot to 18 inches of soil, because that's where your biological activity is. If you have alfalfa, it's going to move down 20 feet. It's just a matter of time, and that's what we see. It's already reached the groundwater. So that as it moves down, you've compromised the resistance of the plant, you've stimulated your soil-borne pathogens, and you've eliminated your natural biological controls that would suppress those or provide nutrients for the plant to maintain its resistance. Very active. Other questions?
Excuse me, I'm just going back two slides ago to down-regulate. Could you say a synonym for down-regulate is chelate?
No, it would be inhibit.
Inhibit, okay.
Be a type. It's a little different, but it essentially inhibit that enzyme activity.
Is that the main thing that's in Roundup?
Well, Roundup is the chelator that changes everything in the environment, essentially, because it changes your soil biology. All of the system in the ecology fits together, and it hammers every one of those aspects. And I'll try and point those out in a little, bring it back together if I may. It's a very potent compound that changes the nutrient efficiency of the plant. Even at 11 grams per acre, half an ounce, and we're usually putting out 450 grams in a single application. Sometimes we're putting 6 up to 15 times that now with resistant weeds. But at 11 grams in drift, it will inhibit the uptake of iron by 50%, manganese by 80%. But then it also inhibits the uptake of iron, manganese, and zinc by 80 to 90% as far as its translocation and ability of the plant to utilize those essential minerals. Some research by Dr. Robert Kremer and Louis Zobioli at the University of Missouri shows that even in the Roundup Ready plant, you have a 500% increase in root colonization by fusarium. We have a new disease, since we have the genetically engineered plant, called sudden death syndrome. This year, the estimates are that it will cost us more than 1 billion bushel of grain. Disease that the pathogen's been around for a long, long time. I isolated it from the Furton farm and some studies I was doing in Michigan in 1957. The pathogen's been there, but it's a new disease because glyphosate changes the soil biology and the virulence of that pathogen, so that now we have that increased infection, even of the genetically engineered plant, because there's nothing in that plant that does anything to the glyphosate. It only makes it possible by substituting or by inserting an additional process that the plant has to expend energy on keeping that pathway open. Now, it's toxic, it's antibiotic activity against those organisms that would suppress the diseases, against those organisms that make nutrients available, some of the hormone producers that enhance nitrogen fixation and other functions. So there are the two systems, or two aspects, that we have to look at to understand genetic engineering. You have the process that disrupts the integrity of the genetic code. And in this soybean variety, you can see that it reduces the manganese uptake about 17%. The iron uptake, or the zinc uptake, by 47%. And then when you add the glyphosate as a strong mineral chelator, you hammer it again, and you really knock the nutrient efficiency and availability of that crop. Many farmers have exclaimed and commented that their crops don't look as good as they used to. And so they'll have an agronomist out, or they'll have a consultant out, and they'll look at the situation. The stand is usually there. It may be slow coming, but the stand will usually be there, but it's just not as vigorous as it used to be. You don't see it unless you have a good side-by-side comparison, as you see with this research that Volker Rahm held at Hohenheim University, established there. But the consultants will look at it, and unless they're aware of the activity of glyphosate, they'll say, well, it was probably because we had a cold spring, or a dry spring, or a wet spring, or too much residue present. We know all of those affect nutrient availability. They don't think of the glyphosate and its chelating effect and antibiotic effect as being the cause for the less nutrient availability and the loss of vigor. And when it's actually just that persistence of the glyphosate and its effect in changing the soil biology. Dr. Guri Johal and Bill Rahe, were the first to identify the herbicidal mode of action of glyphosate. And they set up a study, and they said, well, if it's really shutting down the EPSPS enzyme, the shikimate pathway, that's secondary metabolism. You shouldn't be able to kill a plant. That will be a hormonal effect where you suppress growth, but not kill it. And so they set this experiment up where they had sterile soil and they had regular field soil and then their control, and they found that